For as long as we've existed, we've been at the mercy of the planet. For all our modern marvels, for all our progress, we are fundamentally reactive. We wait for the hurricane to hit. We wait for the river to spill over. We wait for the ground to start shaking. We build walls against the water and shelters against the wind. But our relationship with natural disasters has always been one of tense, nervous waiting, followed by a frantic, chaotic response. The story of every disaster is written after the fact, in the cold language of damage reports, economic losses, and tragic human costs. But what if that story could be rewritten? What if, instead of waiting, we could know? Not guess, not estimate, but truly know. Imagine a city that doesn't just brace for impact, but sees it coming weeks in advance, with a clarity so sharp it feels like prophecy. A city that can watch a catastrophe play out in a virtual world, learn its every move, and counter it before it ever touches a single home or a single life. This isn't some sci-fi fantasy. This is a new reality being built right now in a handful of pioneering cities across the globe. They're creating a new kind of oracle, one built not on myth and mystery, but on data, concrete, and artificial intelligence. And what these AI cities are starting to see is changing everything. Imagine your phone buzzes. It's not a text message. It's a 3-week countdown to the exact moment this street, your street, will be underwater. This isn't a weather forecast. It's a calculation. And the warning isn't coming from a weatherman. It's coming from the city itself. For centuries, we've fought a one-sided war against the raw power of nature. We see the signs, we track the storm clouds, we measure the tremors, but we're always, fundamentally, a step behind. Our methods are a patchwork of past disasters and statistical guesses. A hurricane forecast is a giant cone of uncertainty. A flood warning is a broad, imprecise map of what might get wet. An earthquake warning, if you get one at all, gives you mere seconds. The moments before disaster are a fog of what-ifs, and the hours that follow are pure chaos. We've all become numb to the images. Cars sunk on city streets, families on rooftops waiting for rescue, entire neighborhoods turned to splinters and ash. The financial toll is staggering, a constant drain on the global economy. But the human cost is immeasurable. It's the loss of homes, of livelihoods, of memories, and all too often, of life. The problem isn't a lack of courage from our first responders. It's a failure of foresight. We are fighting a 21st century battle with 20th century intelligence. Our entire disaster playbook is built on reaction. Emergency crews are sent out after 911 calls start pouring in. Resources are sent based on frantic, incomplete reports from the ground. Evacuation orders are issued, but they're often so broad that people hesitate. Will it really be that bad? Here? That's the question no one can answer with certainty. And that uncertainty costs us. It leads to clogged escape routes and a last-minute scramble that puts everyone in more danger. We're always caught preparing for the last disaster, not the next one. We fix the levee that broke last time. We update the building codes that failed in the last earthquake. But nature doesn't play by the old rules. The next flood might not come from the river, but from a city drain that's completely overwhelmed. The next catastrophe might be 2 disasters in one. A hurricane's storm surge mixed with extreme rainfall, a scenario that our separate prediction models just can't handle. This reactive stance is a recipe for loss. We rebuild, but we rebuild in the shadow of the next unknown threat. We spend billions on recovery, a currency of repair and regret, when a fraction of that spent on genuine prediction could have rewritten the entire outcome. We are playing a guessing game against the Earth's climate, and it's becoming more volatile and violent every year. The game is changing, and our old playbook is dangerously obsolete. We've been fighting blind. It's time to turn on the lights. But what if we could clear that fog of war before the battle even starts? What if we could see the catastrophe coming, not as a vague possibility, but as a high-definition simulation? What if we could play out the disaster in a digital world, watch its every move, understand its every consequence, and prepare for it with absolute precision? Imagine a world where an evacuation isn't a citywide panic, but a calm, street-by-street notification sent weeks in advance. A world where shelters and supplies aren't just in schools, but are positioned in the exact spots they'll be needed most. Picture a city where the power grid in a flood zone is intelligently shut down before the water hits to prevent fires, where gas lines are closed before an earthquake wave arrives, and where traffic lights are rerouted in real time to create clear paths for both evacuees and first responders. This is a fundamental shift in our relationship with disaster. It's the difference between being a victim of the storm and being its strategist. It's moving from panicked reaction to proactive, orchestrated resilience. And this isn't a fantasy. It's a tech revolution quietly unfolding in the most forward-thinking cities on Earth. The key to it all is a concept that sounds like it was pulled from science fiction, but is very much real. The digital twin. So what exactly is a digital twin? The simplest way to think of it is a living, breathing, real-time video game of an entire city, built on billions of data points. It is a living, virtual mirror of physical reality. A 3D model so detailed and dynamic you can run startlingly accurate simulations on it. This isn't just a static Google Earth map. It's a dynamic replica of the city, and it's built on 3 key pillars. The first pillar is the phone blueprint. This is the static but incredibly detailed 3D model of the city. Using tech like aerial imaging and LiDAR, which is like radar but with lasers, every single physical asset is meticulously mapped. Every building, from its foundation to its roof. Every piece of critical infrastructure, power lines, water mains, sewer systems, subway tunnels, bridges, and roads. It's not just about shape either. The blueprint knows what buildings are made of, how old they are, and their structural designs. It is the most complete architectural and engineering model ever created. The second pillar is the 4 data streams, which act as the city's central nervous system. This is what makes the digital twin live. Billions of data points from a huge network of sensors are fed into the model in real time. This is the Internet of Things, or IoT, in action. Sensors on bridges monitor stress and vibrations. Sensors in rivers and storm drains measure water levels and flow rates. Seismic sensors in the ground detect the tiniest tremors. Weather stations and satellites pour in a constant stream of atmospheric data. But it goes even further. Anonymized cell phone data provides a real-time heat map of where people are and how they're moving. Traffic cameras monitor the flow of vehicles. The energy grid reports its status. This flood of information turns the static blueprint into a living entity. The digital twin knows not just where the buildings are, but also how many people are in them. It knows not just where the roads are, but how congested they are, right now. The third and most crucial pillar is the brain. This is where artificial intelligence and machine learning make sense of it all. The AI doesn't just see the city as it is at this moment. It's been trained on decades of historical data, past weather events, records of old floods, seismic activity logs, and more. By mixing that history with the real-time data, the AI learns the city's complex patterns. It starts to understand the physics of its own environment. It can now run what are called multi-physics simulations. This means it doesn't just guess where a flood will go. It uses the 3D blueprint and real-time data to simulate the actual physics of the event. If a river is about to overflow, the AI model calculates the water volume and then simulates how that water will flow down streets, pool in low-lying areas, and put pressure on buildings and underground systems. For an earthquake, it simulates how seismic waves will travel through the specific soil under the city, predicting which buildings are most likely to fail. This isn't a forecast anymore. It's a dress rehearsal for disaster. And it's already being deployed. This technology isn't a distant dream. It's an operational reality. Cities are building their digital twins right now, each one tailored to the specific threats they face. They are becoming the first generation of AI-powered oracles, seeing their future with a clarity that was once unimaginable. Perhaps the most ambitious example is Virtual Singapore. Launched as part of Singapore's Smart Nation initiative, it's a multi-million-dollar project to create a dynamic, data-rich digital twin of the entire city-state. It's not just a model, it's a shared platform used across government agencies for everything from urban planning to disaster management. The Virtual Singapore platform pulls in a breathtaking amount of data, from the 3D models of every building and tree to demographic data, population movements, traffic flows, and real-time climate info. For a city-state that is both incredibly dense and vulnerable to climate change, this tool is a necessity. In early 2025, Singapore launched a dedicated digital twin of its port, one of the busiest in the world, called the Maritime Digital Twin, or MDT. With trials set to begin in the latter half of 2025, the MDT will integrate live data from vessels, port operations, and environmental sensors to do more than just make things efficient. It's also designed to simulate and plan emergency responses for hazardous events like oil and chemical spills, modeling exactly how pollutants would spread through the water to allow for a faster, more effective cleanup. Virtual Singapore is proof of a new philosophy of governance. Why wait to be surprised by the future when you can simulate it, study it, and prepare for it? On the Japanese island of Kyushu lies Kumamoto City, a region historically plagued by devastating floods. In response, Kumamoto has embraced digital twin technology with a singular focus: mastering the complex dynamics of water. Partnering with the Resilience Tech Company. One concern: Kumamoto implemented a digital twin that simulates 3 types of flooding at once: riverine flooding, when rivers overflow, inland flooding, when drains back up, and coastal flooding from storm surges. This ability to model compound flooding is what makes it so powerful, because it reflects the messy reality of major weather events. The level of detail is staggering, providing risk assessments down to the individual building. But here's where it gets real. During a period of dangerously heavy rain in August of 2021, the platform was put to a critical test. As the city braced for the worst, the system ran its simulations and correctly predicted that a major river would not flood, despite the deluge. The observed water levels in the river closely matched the simulation's predictions. This is just as important as predicting a disaster. It prevented a costly and disruptive large-scale response when it wasn't needed. It's the power of transforming chaos into a sequence of predictable, manageable events. Few places on Earth know the power of typhoons better than Taiwan. Now, the island nation is at the forefront of using cutting-edge AI to fight back, piloting NVIDIA's revolutionary Earth 2 platform. Announced in March 2024, NVIDIA's Earth 2 is a cloud platform that aims to create a full digital twin of the entire planet's atmosphere, simulating global weather at an unprecedented kilometer-scale resolution. To put that in perspective, that's like going from a blurry photo to a high-definition video. Taiwan's Central Weather Administration is using a generative AI model within Earth-2 called CoreDiff. It takes coarse, low-resolution weather forecasts and intelligently sharpens them, adding fine-grained detail. It learns the physics of the atmosphere, allowing it to generate predictions that are not only 1,000 times faster than traditional models, but also vastly more energy efficient. For Taiwan, this means they can predict a typhoon's path and exact landfall with far greater precision, and further in advance. This capability is being supercharged by a new NVIDIA-powered supercomputer at Taiwan's National Center for High-Performance Computing, scheduled to go live in late 2025, to accelerate this exact kind of climate science research. It's a cascading system of prediction, from the planetary scale right down to the city block. The upside of this technology is immense. It signals an age of urban resilience that was previously unthinkable. The most obvious benefit is saving lives. Accurate, hyperlocal warnings allow for orderly, targeted evacuations, drastically reducing casualties. Emergency response becomes faster and more effective when agencies can see what's happening in real time and send resources where they need to go before they're even called. The economic impact is just as profound. By predicting infrastructure failures, cities can perform preventative maintenance, fixing the vulnerable bridge before it gets wiped out. This is vastly cheaper than rebuilding after a disaster. Over time, this tech will change how we even design cities, allowing planners to test new developments against simulated future climate scenarios. We could see the rise of cities that are not just smart, but actively anti-fragile, able to anticipate shocks and adapt on the fly. But we can't be naive. A tool this powerful always comes with a catch. The very thing that gives a digital twin its power, its access to vast real-time data, is also the source of its biggest ethical problems. The line between safety and surveillance is perilously thin. For a digital twin to work, it needs to know everything. It needs to know where we are and where we're going. It needs data from our smart homes, our energy use, our movement through public spaces. The same tech that can predict a disaster could also be used to predict, and maybe even control, human behavior. The promise of a safer city comes at the price of a city that watches its citizens with an unblinking algorithmic eye. This brings up some tough questions we're only just starting to ask. Who owns all this data? The public? Or the private tech companies that build the systems? How is it secured? A city's digital twin would be an irresistible target for hackers who could shut down a city or create fake disaster warnings to cause panic. And what about algorithmic bias? AI models learn from historical data, which often reflects existing social inequalities. An algorithm designed to optimize resources might accidentally steer investment away from poorer neighborhoods, making inequality even worse. Could an insurance company use a digital twin's block-level risk assessment to deny coverage to people in vulnerable areas? These are not hypothetical problems. They are the critical ethical guardrails we have to build alongside the technology. Without robust rules for data privacy, transparency, and fairness, the dream of the all-seeing city could easily become a dystopian panopticon. We are at a profound technological crossroads. For the first time, we're developing the ability to go from being reactive victims of natural disasters to proactive masters of our own resilience. The convergence of AI, IoT, and simulation is creating digital twins, living virtual worlds that can see catastrophe coming with startling accuracy. This isn't science fiction. In cities like Singapore, Kumamoto, and across Taiwan, this future is already taking shape. They are proving that it's possible to trade uncertainty and chaos for foresight and control. They're writing a new playbook, one where data and simulation are our most powerful shields against a changing planet. The journey is just beginning, and the ethical road ahead is full of challenges. But the potential to save countless lives, protect our communities, and build a more resilient world is undeniable. The all-seeing city is coming. We just have to be wise enough to use its power for the good of all. If your city had this power, what would you want it to see first? A looming flood? The next heat wave? The daily traffic nightmare? Let us know your thoughts in the comments below. And for more deep dives into the technology shaping our world, make sure you subscribe and hit that notification bell. You won't want to miss where we're headed next.